Take your time. Okay. This might have worked already. Let me see. Let me see. Excellent connection. Great. Good to hear. Okay. So that's going. Let me just pull it up on my phone, make sure it's all good. Where's my... how do I get to this? How do I even open my freaking live stream? How do I webcam manage? What does this do? Oh, cancel. Can I share it? Oh, here we go. What's with that? Wait. What the hell? Share. AirDrop. To my phone. Okay. To my phone. Okay, it's okay. It's good. They're trying to get me. Oh no. Why is it lagging? Where was I? Okay, so what am I doing here? We are going to be, of course, as soon as I talk, it's like, ugh. I'm actually gonna probably pull this up in Notion as well. If I pull up Notion.so, let's see. Just do new page. Okay, no, this needs to go into EndNotes, I think, or projects. Wait, move to, yeah, this guy. All right, so this will be notes. Okay, so first thing I want to do is, basically we have 5 megabytes of text, actually closer to 6 megabytes. I did the math. So we have 6 megabytes of journals, and we have an 8K token context window on a local LLM known as Llama 3. Let me just make sure that they haven't updated it yet. No, Llama. So we have Ollama, right? Default one is Llama 3.2, which hasn't been updated in 2 months. Okay, so I think I have the most recent one ready. So let me show you what happens if you try to run this 8K context window on Ollama. So go Ollama, Ollama start. I think just run maybe. Llama 3.2. I already have this installed. If you want to install it, just look up Ollama. It's pretty easy. Okay, so hello. Okay, so you see that was pretty quick, right? Another aspect of this is that we don't need to do a 8K context window. We can actually bring this up to 128K. Let me just make a note of that. 128K possible, but very slow. Let me demonstrate. So Llama 3.2, 128K. Let's see. Yeah, so right here, you can see it supports 128K, which is, I believe, something like 2 to the power of, I don't know, 15, 16, 17. Yeah, so I think it's this number. 131, no. Let me just look this up. Boom, Llama 3.2. Yeah, So 131072 tokens, or 128K. However, we can set it to that. I think I have this. I already tried doing this earlier. Yeah, dev. Where is it? Journal is AI. And if you do, or is it in the other one? Should be an SH file here somewhere. Is it in the other one? Oh God. Where did I put it? I definitely had it here somewhere. Oh, here. No. Where did I put it? Maybe llama? No. Vector DB for some reason. What is this? Oh, this is from earlier. Never mind. Oh, I know. It was in I downloaded some sample app that was supposed to do what I want to do, but it didn't actually do it. It was pretty trash at it because the context window was so small. Okay, rag tutorials, local rag agent, local rag agent.py. I'm actually going to bring this copy context. Let me make this a bit more easier. So go into cd dev, and we'll just do make dear olama config, just to make it obvious. And we're just going to copy those in. So we're going to copy, I think just, or we'll move them. Move local rag. What did I do? Local, wait. Oh, cd rag tutorials, local rag agent. Okay, so move model file into /dev olama config, and we'll also move context update /dev olama config. This is nothing crazy. It's just a little file to update the context. Basically, we just take this model file and we just set the parameters. This is how you set it. So from llama 3.2, so you just use the model and you can just tweak it however you want. Right now it's set to 8192, and I'm going to show you what happens if we set it to this number of the full maximum capacity. And we'll just do context update. That sounds about right. Okay, so olama run llama 3.2. Let's see what happens. Okay, first of all, it's already taking, okay, that was bad. Okay, so if I say hello, okay, can you see how slow that's going? It's like, how can I assist you today? Question mark. End. I don't know, tell me about attention head. The most, oh God. Yeah, I don't have this kind of patience. Now we can also do 16K tokens. I think that was working. It was working okay. It wasn't as fast as 8K, but it was okay. Gotta love the small LLMs. That's not even. It was from that's not accurate, is it? Anyways, you can see. So with 128K tokens, it's very slow, and 128K is still less than the 6 megabytes that we want to use, so it's kind of useless. Let's see what happens if we do 16K. So we'll do 16K. That's going to be 2 to the power of 12, maybe 14. So this number. Let's see what happens. And yes, I'm using VI. I'll open VS Code in a bit, but oh no, do I not have it? Why do I not have it? No, I have it. Here we go. All right. All right, that can do its thing. Let's just see what happens if we do this, or context update, and then we'll do same thing. Olama run 3.2. We'll just do tell me about attention heads. Yes, tell me about attention heads. Okay, see, that's much faster, and that's not that bad. And it also has, you know, a decent. It's 16K is double 8K, so that's it can look at more information than the 8K configuration. However, I want to stick with 8K just because we're going to be doing a lot of inference against Llama, so we need it as fast as possible. And I'm going to use some techniques so that we can keep the questions all less than 8K. Okay, this is just keeps going. Okay, cool. And it's also a bit more of a challenge. Like, you got to get a little bit creative when you have such a small parameter. So what, 8192? Oh, 8192. Again, whatever. Same thing, Olama, and this should be a little bit faster. Be about attention heads. Look at that, blazing fast. Woo! Very nice. Okay. Now, here's the problem with the. Oh no. I broke it. Here's the problem with the 8K attention. No, 8K context window. Now, it doesn't. Okay, this is ridiculous. I have a lot of text, right? So I just made these sample journals to work on. This is a subset of the real journal corpus that I want to work on. The whole thing is about 6 megabytes, all text, which doesn't sound like a lot, and it's not a lot in terms of data, which is good. We're going to use that fact later, but it is a lot of text to go through, and I want to run it against. I want to use Llama 3.2 that I can run on this shitty laptop to do inference against it, and not upload it to a larger model, even if it has a freaking 5 megabyte, 5 million or 6 million size context window. I want to do it all locally. I guess putting it in a cloud is another option, but I feel like that's kind of a lazy way to work around it. So no, we're going to do this all on this laptop. I'm going to even turn it on airplane mode. Just kidding, I'm not going to do that because that'll end the stream. But hypothetically, you should be able to do this even with... oops, did I just kill Llama? You should be able to do this even with... Okay, this doesn't need to be running. I don't think. You should be able to do this even offline, but you can do that after the stream because I'm not going to do this. Okay, so we have some samples from June 2021. These have been edited a little bit just to keep sensitive information out, but as you can see, if you do LSAL, they are about, there's only one that fits entirely in the context window. The rest of them need to be kind of specially checked or pre-processed, if you will, to handle them. Now, if you do cat all into f, lsalf, you can see it's total of 56K, which again isn't a lot. We can easily store that into memory. In fact, we can probably store 100 times that in memory and not have it be a problem. And we're going to use that. That's exactly what we're going to do to make it a little bit better. Now, I'm only going to use this subset because I want to iterate through this really quickly versus running it on the entire data set. But this is a good kind of sampling of it. So let's just see what happens. So if we do, how do we do this? How do I copy a file? All right, screw it. Cat 2021-06. Let's do the biggest one. So, or actually, let's do the smallest one. And I'll show you what I mean. What the problem is with this. Yeah, I know. Yeah, there's some swear words in here, but that is an interesting. We're gonna need to handle that. We're gonna need to, because local models, they'll also be like, oh, you can't. I'm not gonna respond to this if it's swear word or something or unsafe context, but basically we just need to skip over it, and I'll show you how to do that. Now here's the thing. Okay, so let's say you do something like this. Represent the following text. Oh my god. Text in JSON formats, and if you just type this in, Boom. Let's see what happens. Okay. Okay. This is actually pretty good. So yeah, here's the JSON representation of the given text, and it just goes through and makes up its own format of JSON, but mostly works pretty well. Rainbow flags. That's a funny one. That's funny. Let's see. So yeah, so as you can see, it does go through and actually, do what needs to be done. Let's see, which one was this? 26. Okay. Okay. Okay, but here's what happens. So this is the smallest one, right? Now let's take the biggest one and see what happens if we try to do the same thing. So RMF LSL 20. Okay, so 2021 06 19 seems to be the biggest one. Let me just clear this. Okay, that doesn't do anything. So again, so cat of 2021 06 19. So this is a pretty big one. Let's see what happens if we try to send this to 2 with a 8K context window. Or is it an 8K context window? Let me just make sure. I think that should copy everything. Okay, cool. Again, so actually, I'm not even sure. Let me just make absolutely clear. Llama cd into dev cd llama config vi model file. Okay, yeah. Let me just make sure. Okay, and now let's run it again. Llama 3.2, and we'll do what did I say? Summarize this in JSON. Represent the following text. Present the following text in format. And I want you to see what happens, because this is something like what, 16, was it 16K? 23K. So 23K bytes. I don't know how many tokens that is. Actually, this might be within 8K tokens now that I think about it. But it might not. Let's see what happens. So I asked it for a JSON representation, right? Okay. Talk to me. Come on. Talk to me. I'm here for you. All right, what's going on? Did I offend it? What the hell? What's going on? Okay. So it is less than it is less than 8K tokens, I guess, because it's 23 bytes, not tokens. Okay, let's do it like this then. Let's put them all together and see what happens. But as you can see, it also is going really slowly, even though it's only an 8K context window. Or is it? Did I mess up here? If I restart it and I ask it, tell me about attention heads. Okay, so it does seem to be the 8K context window configuration. Oh, damn it. Messed it up again. So either way, as you can see, it works better if you send it like smaller snippets of text. It does seem to work, but let's just combine all these into F and then cat F, so we can get the full 56K. And then we'll do, I think we can do this. Yeah. Let's see if this does what I needed to do. All right, so massive 56K bytes, which might be about what, 18K tokens maybe, if tokens 3 bytes, who knows. Again, Llama run Llama 3.2, and if we do summarize the text in JSON format, and you'll see why I'm doing this. We're actually going to use JSON quite a bit just because. Okay, so this is a lot of text, as you can see. The thing is, you have the context window, right, which is pretty small, and you have this massive text, and then above it you say, please put in JSON format. Basically, it kind of like starts at the end, I'm pretty sure, and it just looks at like this text, and then it kind of like keeps going, but it doesn't see the whole like put this in JSON format. It kind of just forgets about that, and you'll see what it does in like 10 minutes. But it'll basically just look at like the last like 8K of the text, which is just text, and it'll say something like, okay, this is a summary of someone's journal, and it'll completely forget about the JSON part, which is why we can't just say, we can't just like put a command like. So what I want to do is I want to take the full 6 megabytes and I want to ask questions against it. So you can't just do ask a question and then bam, 6 megabytes of text. It's gonna forget the question by the time it like starts producing stuff, starts generating text, it's gonna like the question is gonna be completely forgotten by then. Okay, so if it actually generates JSON code, I'm gonna have to like reevaluate my life, but let's see what happens. And vice versa, if you also do 6 megabytes of text and then ask it the question, it'll only look at the last 8K bytes, and then it'll just answer the question based on the last 8K bytes. But we want to look at the full 6 megabytes. Okay, so see, this is what I was looking for. This it doesn't say anything about JSON. It completely forgot about that. It only looks at the last 8K. So Mount Elbert, for example, this one's pretty interesting. Or pretty telling, I guess. VIF. So Elbert appears towards the end. So if we delete everything, actually, let's see. Yeah, so it basically talks about everything like from this line beyond. Everything else is just forgotten. So you can see it's 1,036 lines, and it only looks at the last. Everything after line 700. So all this from here to there is forgotten, which is not good. So this is what I'm gonna do. So now this is the problem. Let me see how we can work around it. So let's get started with VS Code to make it a bit more visually appealing. Okay. Don't worry about this. This is a completely different project. Okay, so as all good things, we start with GitHub. If I have to log in, I swear to God. Okay, new. All right, let's call it, I'm gonna call it document attention. And you'll see why. We're not gonna do this immediately, but I had a crazy insight yesterday that we can do basically attention like they do on tokens, but we can do it between queries, like user queries and documents. And I'll get to that way later. But for now, we're just gonna do this. So let me just explain what's going on here. Problem with 8K context window. Query plus 6 megabytes of text completely forgets query, and vice versa. Query plus 6 megabytes of text followed by the query only looks at last 8K. Also, larger context windows are slow. Like you saw how slow it was to reply to just hello. Like that was ridiculous. So we need to use 8K or maybe 16K, but for fun, maybe we'll do 8K. All right. So here's the first solution. Solution A. We're gonna do plain old TF IDF indexing. This is just like basically you take text, chunk it up into tokens, you put them in an index, and then you can search on the token to get the text back. And there's also like term frequency divided by document frequency. I actually forget how exactly this works, but it has to do with like how often text appears, like a word appears in a document. So like a part of the entire like database versus how much it appears in the database. And we're gonna do that. And this is pretty easy. As you can see, what we have is only 56 megabytes or 56 kilobytes of text, which is not that much. We can definitely just keep this all in memory. And there's also tools to do this existing, but I kind of want to do it myself just because it's fun, kind of. And it also gives you a good idea of how these things actually work. So let's get started. Solution 1, TF-IDF indexing. But that's not just it. We can't just, if we just like perfect and, you know, as AI is all the rage, we're also going to do basically query expansion. Oh my God. Okay, there we go. Query. Okay, you know, whatever. TF-IDF indexing plus query expansion. So on this text, let's come up with something, right? Let's look at the text. So VIF, where is it? Okay, let's take something like right in the middle. And I wanna look for this. I want it to answer. Let's see. Okay. Okay. Cliff bars. Frisco. Okay. Okay. Here's a good one. Okay, so here's a question. Like, what did I do with Sam? So we went camping and he had a race and I watched the race. But if we only look at the last 700, it's not gonna be able to answer that. And if you only look at the first, whatever, 300, it's not gonna be able to answer that. It's kind of in the middle of this. So we need to look at everything, but how do we do that? We can't look at everything at once, right? If I ask the question, what did me and Sam, just example, what did me and Sam do together? We can say something like, so if we just search for what did me and Sam do together, it will retrieve Sam, but I want to retrieve a little bit more and then feed it. Okay, here's what we're gonna do. We're gonna use AI to expand the query to something like Sam together event actions do, I don't know, something like that. So we want to search for more words, and then we're going to use that. We're going to use TF-IDF indexing, just plain old matching, and then we're going to get some chunks of the document. You'll see why I'm not going to use the entire document. We're going to get some chunks of the document. We're going to feed that back to the AI, and then we're going to answer the question so we're going to answer the original question using the chunks. And the chunks, I guess we'll do like 8 chunks. It would actually be good to have a way to measure how many tokens a document is. Let me just pull up the old the old ChatGPT. Is there a tool to determine how many tokens is there a tool to determine how many tokens some text takes up? This will be pretty useful. Okay, it doesn't provide a built-in tools for calculating. What about tokens consumed or something? Let me just read this. Auto tokenizer, pre-trained model name. What is this? Oh, calculation is happening on your browser. Hi, my name is Anderson. Wait, how would it know? What? Okay, what about this? Check the Olama logs. Okay, that might work. Olama API tokens consumed. Something like that. Oh. Eval count. Okay, I'm gonna keep an eye on this. This is gonna be useful. Oh, in the response. There should be something. What the hell did I just do? Okay. Number or just tokens. Ooh, perfect. Okay. I'm gonna keep an eye on this. Just remember this. URL. Nope. Here we go. Oh, this is all really useful. This is all very useful, actually. How was I not seeing this earlier? I swear to God. I was like messing around with this and I somehow completely missed this. Okay, well, that's great. Let's start with this. Let's start with TF-IDF indexing. I want to split the text into chunks of, let's say 1,000. 1,000 tokens. And then we can feed like 7 tokens or 7 of these like top results into the LLM, and then plus a question, and then it can look at everything and come up with a really good answer. It is cold in here. That's why. Okay, now we're talking. All right, let's do this. So new repository, document attention. Let me see how to do this. Oh, I also have this weird setup on my machine, so I need to. All right, here we go. Why not? We'll call it document attention. That's fine. CD into dev, CD or mcdir document attention. It's it's good because it's uppercase. All right, boom. Get in it. Very British. Yeah, fine. I'll add a readme. I don't care. Get add readme. Git commit first for commits. Git commit. Git branch main. Oh God. There's like a way to do this. It's not this. It's close, but it's not quite. Let me see how I did this. cd./journal viz AI. What is it? Git remote list origin. Close. Git remote origin list. Git remote. Get URL origin. Here's what we need. This is what we need. GitHub personal. I set it up and I don't really feel like undoing it, so whatever. All right, document attention /git. Get remote add origin. And if you mess this up, you can't just re-add it. You need to delete it and then do it again. Please work. Get remote push you origin main. All right. Okay, let's see what happens. All right, cool. Document attention. One watching. Feel free to, clone it, fork it, whatever you want to do. Okay, so here's what we're gonna do. We're gonna copy this. We're gonna move the sample journals into this repository. So let's just go ahead and close out of this. Close out of this. So tilde slash sample journals. So we'll do move tilde slash sample journals here. I think that should work. Okay, cool. And we'll get started. All right, let's just try to ignore this. Yeah, I don't want to make these public, so we're gonna do .get ignore. Get ignore. Oh, there's like a whole way to do this. Let me see. Git commit then ignore. Oh, but you can't commit an empty. Something like that. Let's see. Delete the file. Git update index assume unchanged. Okay, let me temporarily move these out. So it's in simple journals 2020 whatever into tilde slash, yeah, that should be fine. And then we'll do we'll bring this back, but oh, almost just messed it up. Okay, if we do git status, git add dot, and then we'll do okay. Git commit adding sample journal folder. We'll have like a more. I think eventually we're just gonna take a. Oh. Don't want to admit that. Wait. Huh? Oh. Okay. Git push. Okay, so now we have this folder. Okay. The readme just says I don't know. Now, if we do this, assume unchanged from now on, and we'll just do sample. Okay, and now, huh? No, you're supposed to be ignored. Cool. Cool, so everything in there will be ignored. So now we can bring them back. So we'll do move tilde slash 2021 everything into sample journals. And now if we do this, do it again. What the hell? Do I need to like do it manually? Why not? Why can't I do it? Wait, what? Skip work tree? See, this is real development right here. Why not? What the hell? Okay, you know what? Okay, so it's committed, but it's not going to get changes anymore. It's exactly what I need. Is it hacky? Whatever. Don't care. Let's see. All right, let's get started. Let's actually get some stuff on the ground. Ignoring samples to not leak privacy. Okay. Let's see. If I remove sample readme, cool. Okay, it's nice and clean now. Yeah, let's get started with TF-IDF. So we'll do, what do we want to do this? I'm going to give each of these Python files funny names, or not funny names, but like unique names. So we'll call this one TF-IDF.py. I don't know. Sure, why not? Okay, there's actually a lot of good things here that I can look at. There's a lot of, I think it's called prepare.py. You like my stop words there? Okay, there's a lot of good code here that I can reuse. Set no number for easy copying. Okay, so here's what we're gonna do. Let's just open them, see what we have. Let's just do sample dir is equal to sample journals, and we'll do, oh right, I promised I would do VS Code. Now that we have a directory, we can open it. File, open folder, and document attention. Here we go. Sorry about that, guys. We'll do bingo. Okay, so we have tf-idf.py, sample journals equal to sample journals. I should really get Copilot, huh? No. I'll do what I want. Okay, to open it, all we gotta do is I think we take an argument here. Yeah, system argv journal directory is that, and then we do looking for journal entries. os.list there. What is this? Why do we do this? Why do we need to do matching files? Oh, this is like a pre-processing, like pre-processing. Okay, let's just copy. I think we can copy this whole for loop. Looks pretty good. Beautiful. All right, so let's just see what this is doing. So for file path in, oh God, okay, what is matching files? we need to get that as well. Matching file is, where does this come from? Matching files equal to blank. I think I just have a regex somewhere in here. Matching files equal to f for f in files, and there's if arita pattern match. This isn't a bad idea, but the pattern is just going to be this. So matching files equal to f for f in files. So, but what is files and theirs? Files and theirs is, of course, okay, this looks fine. Files and dirs. We can just do files and dirs. Here we go. Files and dirs. If there's an easier way to do this, I don't care. Sample dir. Okay. We'll just replace this with sample dir. Boom, boom. File path. Yes. Okay. We're just gonna print out the date, and with open sample dir as file. How do we use file? We don't use file here, do we? Content is equal to file.read, print date, content is file.read, print content. Date is actually kind of important, much later. Not right now, but eventually. We're just gonna copy the rest of this out, or comment the rest of this out rather. And we're also gonna want to, oh, what? Python REPL. Huh? What? I might be dumb because I've never done this before. Can I just, why can't I type in this? X. What? This is broken. Doesn't even work. It's useless. Oh, wait. Import. Oh, here we go. X is equal to 5. Okay. X plus 2. Print X. Okay. Cool, but I also have a terminal, which is way more powerful, so. Okay, let's get started. Python 3. Oh god, I have to set up a VNV, don't I? Yes, import OS. And everything else. Actually, that's all we need. Boom, cool. Let's not print out content for now. Boom. Okay, we got the few journals we need. And we can read them. Now what? I'm not gonna set up a VN. I'll just break system packages. I don't care. So I want to get metrics on this. This is how I actually prove that it's working better. So let's do something like this. Okay, how do you get time in Python? We're gonna be going to GPT a lot here today. How to get timing in Python. It's probably like so easy, but I just forget. Okay, figured. Time start is equal. Yeah, start is equal to time.time, and then we'll do after pre-processing is equal to time.time, and we'll do print let's do pre-processing time is equal to after pre-processing minus start, and then we'll do print. I like the F thing in Python. It works so much better than in JavaScript. Pre-processing time. And we'll just do pre-processing time. Cool. Okay, I have a typo here. That's fine. Pre-processing time. Okay. Let's just see what happens. Python obviously is going to be mega fast, very fast. In fact, this is probably going to be pretty quick, even when this specific TF-IDF version is going to be pretty quick. So I'm actually going to go ahead and this is seconds. Let's do nanosecond. Wow, is a millisecond. Okay, milliseconds. Boom, boom, a quarter of a millisecond. Because we're not doing anything. Okay, that's a And then we're gonna do something like this. After pre-processing, we're gonna do this. I'm not gonna count the print statement, so we're gonna do, let's do pre-query, or this is more complicated. I'll just get this out here, and we'll do this later. We'll do post-query. I also want to do, and we'll do query time is equal to pre-query minus post-query. I'm getting ahead of myself, aren't I? Pre-query time that time, post-query time that time. Query time is query time, pre-processing time. I also want to get total bytes, so this is I think we do this kind of right. We can just do, can we do print length contents, and that'll give us bytes basically. Yeah, it will. So start time, we'll do total, do corpus size is equal to 0. Corpus size plus equal to size plus equal to len content. Okay. And we'll do milliseconds, we'll do, how do we do this? Pre-processing time divided by corpus size, it's gonna be, no, seconds per byte. Something like that, right? Let's see what happens. Okay, that's very unscalable. Let's very hard to reason with, so we'll do divide times 1000. Okay, still very tough to reason about, so let's do megabyte. It's gonna be times 1024 times 1024, right? Okay. 13 milliseconds per megabyte, which is completely nonsensical. Doesn't make any sense at all. Whatever, whatever. We'll keep the original one of bytes per second just for fun. Seconds per byte. Byte. Throw that in there. Okay. Seconds per bytes. Right. Cool. Very, very cool. Okay. I know I'm kind of just messing around here, but I want to make sure that we do this for every iteration of this process. So corpus size is equal to length of corpus, length of content. We got total content size. Let's do, all right, I'm just messing around here, but okay. Let's just throw in some variables. When we chunk the text, it's not gonna be tokens exactly. So if we say 1000 bytes per chunk, it could be 990 tokens. It could be 1100 tokens. We actually need to send it to the LLM first, but we're actually not gonna send every document to the LLM in pre-processing here. That's why for this specific one, it's gonna be very quick. But we'll still need that chunk size. So chunk size bytes is equal to 1000. Let's make 124, just a nice clean kilobyte. So we're also going to, how are we gonna do this? So you have 4 documents here, right? And then if we chunk it, we're gonna get something like I don't know, 50 documents. And I'm also thinking, do we need to do like hard boundaries? Like here's one chunk, here's another chunk, or do we do like here's a chunk, blend a chunk, blend a chunk. So it would be like 1024, 0 to 1024 in a document would be one chunk, and then 512 to 1024 plus 512 would be another chunk, and then 1024 to 248, and then so on and so forth. I'm leaning towards the second approach just so that we don't miss anything. So let's just see what that looks like. I am absolutely freezing. And also we do need to tokenize and make everything lowercase and remove stop words. So that should be fun. But the chunks themselves will be, how do we do this? I think I'm gonna keep the raw chunk. I'm gonna keep the raw chunk as it is with capitalization and all the fun stuff. But then when we tokenize and index the tokens, we'll do that. So let's just do this first. Okay. So we have content. We want to do something like this. While true, I don't know. And we'll do chunks. They're not exactly paragraphs. I tried paragraphs, but the thing is some of my journals aren't exactly formatted in the best way, so they don't work. Like there'll be one paragraph that's just one line, and then there'll be one paragraph that's like 1,000 lines. It's like the entire thing. Append, right? Chunks dot append. Okay. Let me make notes. Let me make a note just so I can get my. I think I can express myself a little bit better in text. So let me bold this. Let me make this really huge. Okay. Chunking. 0 to 1024, 512 to 1024 plus 512. 1024 to 2048, and so on. At the end, okay, let's just assume that we have a document that's 2,000 bytes. In that case, we're going to want to get like this chunk, but then truncate it to 1024, and then that'll be it. So when we have the start plus, so like 1024 is the start here, and then plus the chunk size, which is also 1024. When that is greater than the length of the content, we're gonna want to break, or we're gonna want to stop. But I think we can do a for loop. For start indexed in range. Let's do. Zero stop. Stop is, actually don't know what the stop's going to be. Stop's going to be this. Length of content divided by chunk size, right? But we need this as an integer. Actually, let me try this. So divide it by chunk size, and then we multiply it again by chunk size bytes. I think this is what we need. So we take the content, we split up into chunk sizes, so that could be something like 8, and then we round down. Floor. Math.floor. Am I stupid? round, maybe. No, but that's gonna go up. Fine, fuck it, math.floor. I don't know, import math. Right, math.floor, okay, cool. And then math.floor chunk size bytes. So this will, if we have 2K, this will give us something like 1, but then, yeah, that's actually pretty accurate. That's exactly what we need. Okay, so we need this. And the end index, of course, is going to be start index plus chunk size bytes. Okay, I think this should about work. Let me try this. Print chunks, and then we'll break just so we only check one file. Oh, right, this is never gonna end. While true, no, we're gonna want to do while start index plus, let's see. I guess it's while end index. But no, let's do this. Start index is less than length of content. I just want to see what this does. We might want to do something like minus something, but I don't know. Okay, cool. While start index is less than length of content. End index is equal to start index plus chunk size bytes, and then we move it along. I think this should work. Let's just see what happens. Nice. str. This is of course length. Oh, this doesn't matter. Okay, perfect. Slice indices must be integers or none, or have an index method. Did I miss something? Can I do this? Okay, so we can do that, but I guess end index is not. Are you kidding me? Ah, I see. Actually, show me the last one. This seems a little small. $285. That's way smaller than that. I think what's going on is the last window is very small. I want to see, but I feel like this whole thing should be contained in. Oh, I just realized we're also like cutting words off. Okay, we might need a little bit more of an interesting strategy here. Let's see what -2 looks like. That's my first week in Colorado. Wait. Oh. And that was my first week in Colorado. So I don't want to copy those. I guess I'm okay with like splitting words in half because that's what we have the sliding windows for. So even if we split a word in half, it'll be in the next window. It'll be like in the middle of the next window. Yeah, you know what? Let's do it like this. Length of content minus chunk size bytes over 2. I think this is gonna do exactly what I need it to do. So if I do -1, this should be the same text that we just printed out. Yeah. Okay, cool. So that way the last chunk isn't like a tiny snippet. Morning.
Happy Thanksgiving.
Happy Thanksgiving. Let's see. All right, so we have the chunks. The chunks will be documents. And now, for each chunk, we also will go ahead and tokenize it. And let's just go over what tokenization means. We don't need this. We don't need this anymore. So we have chunks. We actually need to save these somewhere, especially once like pre-processing takes a while. You definitely want to save this to disk. Okay, so we have a chunk. What do we do with it? We probably want to give it some kind of ID. What the hell? For chunk in chunks. Let's start the tokenization. So I'll make a new method here because this is going to be pretty huge. Def tokenize. Yeah, we just need to tokenize. We don't need to do anything else. Tokenize, we'll do text. And that's where the magic happens. Let's just do print tokenize chunk. And then basically we associate every token to the chunk. We also need a unique ID for each chunk, so we'll do for I in enumerate. So we'll have document A chunk 1, document B chunk 2, etc. So I'm just going to do print I chunk or I len chunk. How much chunk could a chunk would chunk if a wood chunk could chunk wood? Okay, very funny. Let's just return empty for now. Okay, so we have a bunch of chunks here, and what I want to do is actually we're gonna have an ID. This is gonna be date plus I. So we're gonna have a bunch of IDs here, and these IDs are gonna be pretty useful, as you'll see. Date plus I. What's wrong with you? Let's do something like right? Can I do this? Date hashtag. See what that looks like. So we got a bunch of IDs. Okay, cool, perfect. This is exactly what I need. So ID is useful later because we're gonna have a index thing, which is a index obviously, and we're gonna want to associate. Actually, we'll get to that in a second, but let's just do this. For I chunk and enumerate chunks, we got this, and we're gonna go ahead and tokenize it, which is just gonna return empty. We can not do this anymore. Let me just save this because we have something good going on. Git add dot chunks ready to tokenize. Git push. Cool. So when we tokenize, what we need to do. There's like a lot of ways to do this, but I'm gonna call exit -1 just so we can see what we're doing with like the first chunk. And we're gonna do text dot split on boom, and we're gonna do. We also want to do indexing based on index, maybe. But we're just gonna keep it super rudimentary, lowercase. Python lowercase lower long, or is it dot lower. Okay, well that one's not giving an error, so I'll keep that one. Right? Cool. Let's see what happens. Okay. Denver. Empty line. Okay. I mean, these look pretty good for the most part. We're probably going to want to put them in a set. So, token. We don't want to do a set because we want to maintain how many times a token appears in a chunk. So this is going to be a bit more interesting. I could just ask GPT to do this. Yeah, that'd be pretty easy, huh? Yeah, screw it. I'll just ask it and then I'll explain everything. Give me basic tokenization code for give me a basic tokenization method. Let's see. Tokens and punctuators. What? No, that's too easy. Actually, this is not a bad idea. I don't want to use regex. I think it's slow. No regex. No regex. Just do split. Without regex. Text.split. Wait, that's... Handle new lines, please. Is it really that easy? Do we not even need this? Will it work better if I do this? Yes. Okay. Well, this is, you know, as you can see, it's very fast. Oh, well, this actually went up a bit. Actually, it takes a little while per megabyte, but only because we're printing it. All right, keep the exit -1. I want to break this down. All right, so we also, so I think it's pretty obvious what's going on here. We have a bunch of words split into tokens. Now, I want to associate, actually, we just want to return this. I think this is fine. But once we call this, I want to print tokenized chunk. Don't do that. Let's do instead tokens is equal to. I'm not going to remove stop words for now. I'll show you how it works with stop words and without stop words. We can just modify that tokenize function later. Tokenize chunk, and now we want to associate each word with the chunk. So we'll do for token in token. In token. How do we do this? We do index token. Oh, there's a thing in Python. There's a thing in Python. Was it counter? Because I don't want to initialize it every time. Counter. Yeah, this is exactly what I need. Or is it? Oh, it's just a counter. It's not a, okay, whatever. We'll do it manually. Index token is equal to, or no, we need it's a, this is called a posting list. So you might see this word like northeast, for example. It's going to appear in this chunk. It's going to appear in another chunk. It's not going to appear in some chunks, but the chunks that it appears in is going to be a list. It's going to be, and it's called the posting list. So let's do this. If There's a classic method pattern right here. If token in index, actually if token not in index, index token is equal to, oh my god. We also need to keep track of term frequency for documents, so it's not going to be that simple. I think we're going to need we're not just going to need an array, we're also going to need an array of okay, let me describe what I'm looking for. So index needs to look like this. So we have I don't know, northeast, and we're going to match that to an array, but in that array we're going to have something like chunk 1 or document rather, chunk 1, and it's going to be frequency 2, something like that. So we need to do this, and let me just make it a bit more clear of what we're looking for. Okay, so not only do we need an empty array, we also need to check if or do we want to do something like this? This might work better actually. A dict of dicts, right? What the hell? What did that wizard do? Silly ass. We do chunk 1, 2. But then that doesn't allow us to store much more information, does it? Actually, I think we have to do this. Or at least we at least need something like this, like inverted document frequency, term frequency, inverted document frequency, like term, wait, how does it go again? Like global frequency or something, like 20. So it has to be an object. This has to be an object. So this has to be an object no matter what. Global, sorry, frequency 0, right? What? This? Yeah. Okay. But then we need something like this. Document, or like matches, and then this can be, matches can be an array object or a dict object. I'm not entirely sure, but let me just refresh myself on what this is real quick. Term frequency, inverse document frequency. Put this in like the most simple terms possible. Okay, as a measure of a word, inverse document frequency. I mean, we could do just term frequency, honestly. Okay. Decreasing the weight of common words. So it's divided by, wait, shouldn't it be document frequency inverse term frequency then? Oh, okay. I guess it's just weird. Okay, so number of times a word appears in a document. Okay, so this is term frequency. And this is going to be like per document. And then we have inverse document frequency, which is how much it appears in the entire term. And it's a measure of how many other documents in a corpus contain the word, not how many times it appears in the corpus. So, okay. So how many documents contain it? Okay, cool. Okay, so, okay, I think I get it. We'll figure this out in a second. Let's see. Is it also logged? Okay, whatever. So, again, looking at this thing right here. Okay, we're gonna have to do matches. Screw it. Matches is going to be, is this going to be an array or is it going to be a list? Or is it going to be a dict or a list? I'm leaning towards list just because posting list, but if we make it a list, we're gonna have to go through the list and find the document. We're gonna have to find the chunk ID. So yeah, let's make it a dict just so we can keep that simple. Okay, so if it's not an index, we're gonna initialize it like so. Okay, you know what? I'm starting to think that document frequency is also not something we can compute right now. I think we need to go through the entire corpus and then we compute document frequency. So I'm gonna leave this out. Because we don't really have information here to like see like if the token has already appeared, so we might double count it. So whatever. Okay. Anyways, if token is not an index, so if we haven't seen the token like northeast anywhere in the text before, we're gonna have to do this. Now, maybe we have seen the token. I mean, at this point, it's initialized. Either we've seen it before in a previous chunk, or we're seeing it, or we've already initialized it here because we didn't see it. So, Jesus Christ. Then we're gonna do if chunk if ID not in index token matches. Can we do this? No, it has to be matches. Okay, matches. So this is if we haven't seen the token before in this specific chunk. So for example, something like I appears twice. So we're gonna have to count 3 occurrences of I. I mean, I is a stop word, so we're gonna remove it eventually, but that's just an example. If ID is not in index token matches, then we're gonna have to initialize it like so. Index token matches ID is equal to, is this just gonna be 0? Is this, oh, can matches be a counter? Let me come back to that in a second. Okay, yeah, after some thought, matches counter, I believe. Okay, I just had the documentation up. Where are you? Counter. Sounds good. What? Yes, it is. Stop lying. Okay. Matches counter, matches ID, and then what do we do? Plus equal to 1. Plus equal to 1, right? I think that's correct. Oof. I think I like this. Okay. Wait, but what if it is in, okay. That's the beautiful thing about counter. We don't need to worry about this. All right. So now we have, for every token, for every chunk, we go through every chunk, we go for every token, and then we have a index, and we have the number of matches for every chunk. Okay, I think we actually need to go through this entire thing first before we can do the next step. But the next step is to go through index, go through every token, and then determine document frequency, which I don't think should be too difficult. All we got to do is this. Actually, I just want to see what it looks like right now. Print index. Let's see. Yeah. Nice. What? What do you mean? What? Ah. What? Please. Fine, whatever. Collections. I love collections. Love collecting stuff. Has one match in this document, this chunk, and it appears once. Pretty cool. I think we can do something like this. And this will show us all the tokens. Yes, perfect. Okay. Let's just do 0. I just want to see something real quick. Ooh, not subscriptable. Why not? Is this a set? What is this? Predict. It's addictive keys, whatever the hell that means. What? Makes no sense. Oh well. Is not subscriptable. What do you mean? What did you just print out? Is it not an array? Oh, do I have to do this? What? What are you printing? Hold on. Stop printing. It's confusing. Okay. As you can see, I don't use Python too much. It's a parentheses. What is this? Dict keys. Cool. Okay. Let's just do like index Denver. This will be pretty interesting, I think. Okay, perfect. So we have 1, 2. So it's only ever in one chunk. Now these chunks are kind of arbitrary. It might be better to actually keep the documents as is. Unfortunately, the documents are way too large to put into the AK context window. So that's the whole problem. Document for another thing is about counter. If we need to store like information of where the token appears within the chunk, then we can't use this. We need to use a more advanced structure, but for now this is fine. Okay, so here's what we want to do. We have matches. We also want to do how do we do this? How do you iterate over a list? Key value in index.entries maybe. Print kv maybe. Exit just to make sure. Or break. Items. Yeah, that's exactly it. Okay. Matches. Okay. Oh, this is actually pretty easy. V dot. This is. We call this term frequency. This is term frequency. V document frequency is equal to in V term frequency. So this is the counter. That size, I don't know. Nope. Frequency. Keys. Oh, is it just, no, it's just this. Document frequency 8. 1, 2, 3, 4, 5, 6, 7, 8. It appears in 8 chunks. Perfect. Perfect. That's literally, you can probably do this with a list comprehension even. Do we need keys though? Can we just do this? Can we just do this? Yes, we can do that. That saves a bit of time. Actually, let's see how much time it saves using our fancy metrics. 200, again, 213 milliseconds per megabyte, 192. But if we get rid of this, doesn't make a difference. If we get rid of this though, also doesn't make a difference. If we get rid of this, whatever. I'm kind of messing around here. I know print slows it down. Watch this. Maybe not that much. Oh, okay. Now what? Now we're going to process it a little bit later, but now this is where the AI actually comes in. A little bit more interestingly, but you know, whatever. Another thing I realized, we also need to store the chunk somewhere. So we need to do something like index. This should be separate. This shouldn't be index. This should be like store or something. And then it points to the store. So this is pretty easy though. If we have ID, we're just going to do something like store ID is equal to chunk. And this will keep the raw text. Of course, what is store? Boom, store. So this will store the chunks. If we did this for, how do I put this? So in the posting list, we have a mapping of like words, like Northeast, to a list of chunks. And these chunks have like IDs. And the store will be a mapping of these IDs to the actual text. And that's it. So we can do something like, this is basically what we're going to do. Let me show you. So we're going to do, let's do index, Denver. Let me just show you. Print index Denver, right? Let's do term frequency. This is basically the posting list. And we have that counter, right? Can we do something like keys? I don't know. Nothing like that. Okay, dict keys. Python get first key from dict. Okay, list. This is this is what we can do, right? This is what we can do. Let's get the first one, for example, 0. Boom. We have this, and we can do, now that we have that, so we can do print store. Boom. Boom. Okay. This is pretty convoluted, but boom, look at that. Just from Denver, we got this whole chunk. We got this whole 1024 byte chunk, which I think is pretty cool. Right? So there we go. This is basically what we're going to be doing. We're going to go through, we're going to take a term, like Denver's the query here. We're going to basically do this. We're going to get a bunch of things like this. We're going to get the best scoring ones, and we're going to send them back to the LLM. Now, for now, I just want to do this with, we're not going to query expand the query. We're just going to do very basic TF-IDF. So now that pre-processing is over, we can actually take a query. And I actually want to do this for every query, so we're going to have to rethink this a little bit. Okay, how do we do this? How do we do this? Always make sure to close your tabs, otherwise it goes crazy. Input from user. Input, literally that easy. Query is equal to input. Send query. I think we just do this, right? Denver. Like we're gonna pretend it's an LLM. Like, tell me about Denver, right? And what we're gonna do is the following. We're basically gonna do the exact same thing we did to the tokens. We're gonna do tokenize, and obviously we're gonna run this in a loop. But actually, yeah, you know what? Why not? While true, fuck it. Something like that. Pre-query time.time. Once we get the query, we start the timer, then we do response, everything post-query, and then we give a query stats. Let's do query stats. We're gonna do query time, milliseconds. Corpus bytes. Corpus bytes doesn't really make a lot of sense. We're probably gonna want to look more at, what are we gonna look at? I don't know. Maybe we want to do corpus size, because it's like if you ask a question against 5 gigabytes versus if you ask a question against 5 megabytes, which one's better? But I also do want to do something with how many chunks we look at. So, but we'll get to that in a bit with the LLM. Okay, so now we are in the pre-query phase, or we're in the query phase rather. So tokenized query is equal to tokenized query, of course. And we're gonna do print, just print this just to make sure. Tokenized query. Let me see. Boom, Denver. Okay, cool, perfect. So now we're gonna do exactly this. Pretty much, a bit more intricate than this, but how do we do this? We want to get a bunch of posting lists. Okay, this is tough enough for one word. Doing this for multiple words, it's kind of tricky. We probably want to do an or. So if you say, tell me about Denver, we want to get posting lists, tell me about Denver, and merge the posting list, not and the posting lists. How to do this? And the counter.keys right here, this is basically the posting list. We also need a score, so we're gonna do TF-IDF. Yeah, let's just evaluate them. Let's just evaluate them. Now, TF-IDF can be done without this index. We can just, as we get a query, we can just go through, but the index obviously makes it much faster because we don't have to go through everything. We can just go straight to the index. So let's do this. Let's just get score chunks for every term in the query. So for token in tokenized query, we'll do index token, right? Now we have a lot of information here. We have term frequency. We also have document frequency. So our index token, we'll do something like index entry is equal to index token. We'll do document frequency. My hands are cold if you can't tell. Index frequency, index entry. You know what? Let's just do this. Let's do this. Document. No. Document frequency is equal to document frequency. I haven't even gone to the AI part of this yet at all, and I'm already cooked. Okay, you'll see why. Where do we do this? Here. Can I do this? Term frequency. Is this valid? It is valid. Right? Wait a minute, what? Oh, right, the counter, and then you increment the counter. Right, okay. Let's just do document frequency. This is gonna change it, but that's fine. Term frequency. Good. Okay, so now we can do this with completion in QVS code. So we have document frequency. We also need term frequency, which is the counter. So term frequency, frequency is equal to index entry term frequency. All right, we have A and B. So we have TF and we have IDF. We need to sum IDF though, so wait. What the hell? What's the point of TF? What's the point of this guy? TF IDF. Give an example. Okay. What? Wait. I think I had this wrong. I think I messed this up. Document. Oh, okay, got it. So term frequency, it has to be divided by the length of the document. Got it. The length of, so that's actually the length of tokens. So how many, okay, that's, okay, so this is gonna be, so the TF, so this guy, no, these guys are gonna be stored as, Okay, so we also have to do, we need to divide, once we get the term frequency, we need to divide it by length of tokens. Cool. Okay, so once we have this ready, so once we go through a chunk and we have the tokens, what we do then is this. We do index. Oh, fuck. Well, okay. Well, instead of just appending it to 1, we can do 1.0 divided by length of tokens. And we should probably save this because it's very important. Document length is equal to length tokens. And this is going to be pretty uniform because we're doing like a set amount of bytes. So it's basically going to be somewhere close to how many characters there are. It's going to be 1024 divided by the average English word length. But still very useful for calculations. Okay, document length. Cool, document length. This might work, I have no idea. But this is a good insight because if we don't do this, then document frequency is useless because document frequency is constant for each term. But with this, wait, but then this is also kind of constant. Oh my God. Okay, I think the idea is like if you have a document that's just full of the word northeast, this is going to be really high, but then this is going to be low. So you divide high by low and you get high for that document. So it matches. So if you search northeast, it matches that document very well. Let's just see what this does. Okay, I actually need to see it. Show me index. Show me index. Print index of Denver. I'm not getting any errors, so I assume the counter is working fine. Okay, perfect. Not sure how I feel about this. I think it might be better to store like the raw count, like the integer count and the integer. No, okay. I don't know what I'm worried about. It's like memory is not a problem. It's the AI being slow. That's the problem. Someone texted me. 1 second. Looks delicious. Happy Thanksgiving. I'm actually hungry. I know it's Thanksgiving, but like, whatever. I finally have time to work on what I need to work on. Okay, cool. Okay, so raw count could have worked, but I think it's better to normalize it to the document because if you have a very long, we're not going to have really long chunks, but if hypothetically we had a really long chunk, it could just dominate the rest of the words basically. Okay, now we can do this. Okay, so we have term frequency, we have document frequency. Now term frequency is kind of like the posting list, so we're going to do for posting list post, I guess, in term frequency. I think dot keys maybe. Term frequency dot keys. This is chunk ID. This is chunk IDs. List of chunk IDs. Or no, we don't. I think we can iterate through this, right? Post in term frequency keys. What do we want? What do we need? We want the counter is term frequency. So if we do term frequency post, or this is ID. This is ID. This is chunk ID actually. Let's make it clear. Chunk ID, term frequency chunk ID, well, I guess this is just gonna be score. Score of the chunk ID. Score of the chunk itself is gonna be term frequency chunk ID divided by document frequency. Cool. Now we can print score and chunk ID. This is, I think, exactly what we need. And then we can go to store later, and we can get goods. Denver. Okay. So as you can see, they're all very similar. Probably because Denver just appears once in each of these, but yeah, it only appears once, doesn't it? Should we make larger chunks? Okay, just for now, I'm gonna make the chunks a little bit larger. We're gonna make them 2048. And I think you'll see that Denver will appear twice in some of them, and it'll appear once in other ones. Okay. If we do Denver, what? Oh. Am I stupid or something? Wait, let me try again. Denver. Are they just like equally spaced? Like, okay, fine. What is it, 4096? I'm trying to get them together. Okay, 13 and 14. Maybe they can merge or something. Denver. Okay, so as you can see, 2019 06 19 7 had it appear twice, so it's double the score of the other guys. The other guys only have a bit of variation, probably because they have fewer tokens, so Denver is more of a percentage of tokens. But here's the cool part. Because we're using an index, we're only getting chunks that have it. So notice we have 0, we have this guy, we have this guy, we have this guy. We actually we skip a lot of chunks, and we actually do this very nice. We do this taking no time at all. We actually skip time. But as you can see, this happens very quickly, like less than a millisecond to do this. When I first tried this, I had an idea of going through every chunk in every document, sending it to the AI, being like, is this relevant to, some query? This took days because I have something like 500, it's 6 megabytes. It's 6 megabytes, right? But as you can see, this is pretty quick. Right? Okay. So very quickly, in just a quarter of a millisecond, we can filter out relevant information. So now we're going to send the most relevant ones. I mean, Denver appears a lot in this specific entry, in these specific texts. Let me try something like Billy. Okay. So as you can see, they definitely have very different scores depending on, whatever, maybe Sam. Yeah, so as you can see, they have different scores. Oh, we're still using the larger Sam, for example. Again, less than a millisecond, and sometimes it appears more than other times. All right. I mean, this is just one way to do it. You'll see towards the end, or much later, I have a much more interesting theory on how to do this. Now we actually want to sort these based on score, of course. So let me just do this real quick, and not exactly cheating. It's just I mean, what is cheating really? It's not. This isn't a fucking test. I can do what I want. What? The hell are you talking about? After getting score, sort by score, and print top. What do we want? 7? I'm gonna have to hard code 7, but yeah. Lucky number 7. Okay. Here we go. Yeah, we probably want to do this exactly. Boom. Ooh. Okay. Term frequency, document frequency, chunk ID, scores dot append. Okay. Cool. Oh, we need scores. I think that should work. This is a classic technique. Print score chunk ID. I think this is what we want. So if we rerun this, do fun stuff. Yes, very fun. Here we go. So if we do Denver, again, the scores don't really vary that much. But if we do Sam, okay, see this one. So these two have a much higher score than these. So suggest that he's mentioned more here. Now, just mentioning someone or something more in a sentence isn't necessarily indicative of like what we want to know about him. Like, how do I put this? Maybe you want to say like, what is Sam's birthday? Maybe Sam's birthday is mentioned in this guy, but we only look at like these because top 7. And this one just happens to mention Sam a lot. So this isn't like ideal, but whatever. Let's see what other text we can get. We get I. That's a classic stop word, one of my favorites. But as you can see, because it appears in every document, it doesn't actually get scored that high. For example, okay, never mind. It does get scored pretty high. What about hike? Okay, so hike doesn't appear in a lot of documents. It only appears in a few, maybe. But because of that, the document frequency is lower, so this gets scored higher. Whereas something like I, which appears in every document, so it should have a high term frequency, it also has a low document frequency because it appears in every fucking chunk. But yeah. Anyways, this is useless. What you really want to do is this. Store. We should probably call it chunk store. But yeah, why not? Chunk store. All right, so now this is where it gets really fun. And we're finally going to connect to Llama and do it much faster, shittier, with a very rudimentary retrieval method, but faster. Watch this. Now if I type in Sam, oh, now we get information about Sam. What is he up to? I love the random split. Actually, you know what? Let's only print the first one, because we have the sorted scores. Sorted scores is most important, and this is just for one token. We need to do this for multiple tokens. I'll show you how to. Whoops. Sam. All right, so this is the one where as you can see, Sam appears here, and Sam also appears here and here. So this is like the most Sam chunk. We can also do something like campground. That's a good idea. Campground. Again, I think this is the same chunk, but campground. This is the highest scoring one. Yeah. So cool. What are we gonna do with this? We're gonna go with the chunk store. And I'm probably underutilizing the 8K context window because bytes don't really correspond to tokens, but whatever. Oh, we still need to combine documents. That's a good question. Like if we do something like Sam campground, we're not really combining scores. We're just going through the for loop twice. So what do we do? We want to OR them, right? But how do we combine the scores? because these chunk IDs are good. These chunk IDs are good, and these sorted scores are pretty good. Or rather, just scores themselves are pretty good. But how do we combine the scores? Okay, let's see if this suggests anything beyond terms. Okay, citations, visual words, bag of words model, weighting factor. Oh yeah, without word order. That's the thing that sucks about this. That LLMs do much better. Derivatives, maybe. Cold. Okay. If you have a term and you have a document and it has one score, then you have another term and the same document and it has a different score, how do you combine the scores? Is there any indication here? Okay, I guess I'll have to ask the thing. Okay, using how do you combine and rank posting lists for TF IDF with multiple terms in the query? Like, how do you do this? Retrieve posting lists, yada, 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 calculate TF IDF score for each term in each document. Okay, and then what? TF IDF, yada, yada, combine posting lists. Cumulative score for each document that appears in any posting list. Yes, exactly. That's exactly what I want to do. You add the scores. Is that right? All right, let's see what happens. I guess score should be a counter then, huh? Yeah, precisely. For token and combined queries. So let's do combined scores as like more important is equal to collections.counter, right? Yes. Okay, so for chunk ID in frequency.terms, score is the same, but instead we're going to do combined scores plus equal to, chunk ID plus equal to score, right? And then that should be it. That should be all we need to do. And we can just do same thing for this, except sorted combined scores, and I don't really care about this. And this should have higher scores than what we've seen. Like if we do Sam Campground, it's going to combine the scores for Sam and Campground for a given document. So this is, we're going to see higher scores now. I think this should still work, but I don't know, maybe not. What the fuck are you? There we go, combine scores. I don't know if this will work because this let's see. Counter, then how do you rank it? What? Most common? How is it so clever? Let's see if this works. Sorted combined scores is equal to combined score the most. Holy shit. Dude, I'm kidding. I mean, it probably does the exact same thing, but yeah, exactly. Okay, most common, and then we'll do same thing. Basically this. Boom, boom, boom. Okay, sorted combined scores, -1, Actually, yeah, let's get top 7. I want to see this chunk store, chunk ID. Let's just do chunk ID for now, but eventually we're gonna want to get chunk store, and then we'll finally feed that to the LLM as promised. I know. Okay, I think this is what we need to do. Let's just see what happens. Sam. Okay, this is gonna be identical, obviously, but why are you printing? It's printing out something else. I don't know what to do. Okay, actually has scores like 0.000